and also the program manager of the Watt Balance program. So welcome, Dr. Carsten.
Thank you. Good morning, ladies and gentlemen. Yes, thank you for the introduction, Penny. There we go. We haven't lost it. So let's start, because I see we're already a little bit late. So yes, I am. How do we get this out? I think we'll have to do it like this, otherwise we need to stand there all the time. So yes, I'm looking after the revised SI program, and the Watt Balance, Kibble Balance is one of our exciting projects. So this talk will be in two parts. The one, I'll quickly touch on the different programs that we have at NAMISA, and then I will look at the revised SI program in NAMISA and the different units that will be revised very, very soon. I must have a disclaimer at the beginning. A lot of the slides that I have is not my own slides. It's liberally borrowed from people at NAMISA. So if you see something that belongs to you, thank you very much. Okay, so this would be one of them. I see people are smiling. So this is still a little bit old, but it actually explains to us how NAMISA think of working in, how our programs work. We have here the traditional metrology programs, where we have what is chemical and chemistry and materials, physical metrology, and the units that we maintain there, and then the finance and all the corporate services. And the plan with the programs is that we take people from different areas, put them together to actually achieve what we want, because there's skills that sits in different of these, what we call silos, and we would like that we actually work together then. And the Kibble Balance, Watt Balance is a very good example where this worked very well, because we've got people from the mass lab, we've got people from temperature, we have people from DCLF, we've got people from AUV, so we work across the fields. So here's a list of the current programs that we have in NAMISA, with the program manager and the sponsor, the executive person responsible for the programs. So you can see we've actually got quite a lot. We've got the revised SI program, manufacturing competitiveness, quality of life, energy efficiency, materials, reference materials, green economy, advanced measurement solutions. Then we've got this regional and international integration. That is also quite an important program for us, for all our cooperation with people worldwide. And then last but not least, our commercial services, where we actually provide a service to the industry, mainly in South Africa, but also in the whole of Africa. Okay, this slide's got a little bit more detail on the programs, but I'm not going into detail on all of them, because it's really not my field of expertise. So we've got the reference material program, where they have the African Feed and Feed project. So this would be the programs, and this will be the projects in each program. There's the African Feed and Food program, primary reference gas mixtures, ethanol and aqua solutions, and nanoparticles. In the green economy, they're looking at air pollution. It's what the name says, they're looking at the green things for us, the monitoring of the environment, including the nuclear monitoring. Then there's dioxins and mycotoxins and POPs and all of these things that the chemists know about. And clean energy, which in South Africa is a very important thing for us as well again. The energy efficiency group look at solid state lighting, power and energy, smart grids, which is a very new field for NAMISA, and the AC/DC transfer difference. Manufacturing competitiveness, we want to become a bigger role player there. So there we have the more traditional physical metrology fields like coordinate measuring, dimensional things, additive manufacturing, and the characterization of materials. The next one is the advanced measurement solutions, where we look at new and advanced things. Now this is going away. One of the programs there is our projects is looking at the accurate timekeeping for the square kilometre array in South Africa, which is an international cooperation project, and the time looking at time and frequency transfer through optical fiber, which is quite exciting for us, and process monitoring. Then quality of life is another big program where we really want to look at the quality of life of our citizens. So it's life, health, the law enforcement, that people don't drink and drive, how much they can, what is tolerable, medical devices, and the protection of the consumer. And then the last one is our revised SI program, where we have the project on the Watt or Kibble balance. We work a little bit in the Avogadro project, and then some quantum standards and thermometry that I will talk about a little bit more. Okay, so now if we go to the revised SI program, some of these slides would be things that you've seen already at this conference. So yeah, we know that we want to change the way that we refer, or that we define the constants, define the units in terms of constants of nature. And why is that important? I mean, these changes has been happening over the last decades. Things, measurement solutions become more and more accurate, and I think that's one of the aims for these fixing all the units in terms of natural constants. If you think about cooking spaghetti, if you overcook or undercook by a few seconds, nobody really worries about that. But if your name is Usain Bolt and they miss a few seconds in your time when you're running and trying to break a record, that makes a big difference. So really it's wherever it's in different fields, you need different accuracies. Okay. So which units will be redefined? That's been mentioned a few times here as well. So it will be the kilogram, the mole, the Kelvin, and the ampere. And we had quite an interesting talk this morning on possible ways for the new ampere, single electron counting. So why? I think there's been a lot of talk about that. The last artifact. We don't want to send our stuff to PIPM all the time. So now the next thing is this something difficult or easy to do? Obviously, it's not that easy to change an artifact into a new standard. So yeah. But that's been decided, we will do that. And so for those that don't know, we in South Africa actually do have a copy of the International Prototype Kilogram. We have copy number 56. This slide has also been shown already during the conference, where we see that there's this drift between the IPK and the other copies that were made of the IPK, and the drift is about 50 micrograms on a kilogram. So it's only 0.05 parts per million. What does that really mean? So if we think about what is 50 grams, if you have a fingerprint that you leave on a glass and the police try to take that off to try and see who's the culprit at this place, that fingerprint apparently weighs about 50 micrograms. Same with eyelashes, one eyelash. So that's how much one eyelash is the change in the mass of the kilogram, and metrologists are worried about that. Most other people wouldn't be worried, but as metrologists, one eyelash is costing us a lot of money worldwide and time. Okay. So yes, we know that it's been decided we will define it in terms of Planck's constant. It's been used in quite a lot of physical fields, so that's important. Was it difficult? Yes, it's very difficult and very time consuming. And the decision was to try two methods. The one is the Avogadro project, where they have a silicon sphere, and one can measure the dimensions there, that's been mentioned before. And then the other way is the second option, where they wanted to weigh mass in terms of something else than mass, not to refer it to mass. And that's where the Watt balance comes from, where you measure gravitational force in terms of electrical forces. And as you all know, it's been renamed to the Kibble balance in honor of Mr. Brian Kibble, who's the father of this concept. There's a picture of the NPL Kibble balance before they've sent it to NRC. And for those that can see, still one of the people working a lot on the Kibble balance is Ian Robinson at NPL. Okay, so if we look at the silicon or the Avogadro project, what do we have? We have a round ball. They say it's very round, so we need to determine how round it is, what's the diameter. We need to know what's the lattice structure, and then all we need to do is actually start counting the atoms. And if you count and count and count, eventually you will know how many atoms there is in this sphere that we have. And we had a lecture on the molar mass yesterday, and then we can figure out what's the mass. The issues with this is this pure silicon? Is there some things that's here that's not plain pure silicon 28? How round is it? The sphere, is it the same roundness in all directions if you tilt it around? And the surface layer that grows with time. So, what is our contribution to this project? Nemisa has got a copy of one of these spheres that on loan from PTB. What we do is we monitor the mass of the sphere to look at stability for them, and we monitor the oxide layer. We've got an offcut of the material from which the sphere was manufactured, and the people then monitor the thickness of that layer, and there's hardly any growth at the moment, but we will keep on monitoring that. And we are looking, Nemisa's got their own silicon sphere as well that's been manufactured 20 odd years ago, and we're now planning to use that sphere as our density standard. Our contribution to the Kibble balance, I'll show that to you in a moment, but just a recap on the Kibble balance. It consists, it's basically, I can't do the dance like Jennifer because I've got too many things in my hand at the moment. She showed us a very nice Kibble dance yesterday. I think tomorrow evening we should actually try and do that. So we'll ask her to do that again so that we can videotape that and then have a competition tomorrow evening. But okay, so back to this. So here we've got the equal arm balance concept. In the one part we we put the mass piece there. We look at the forces. This is our equation. The gravitational force on the mass equal the magnetic field, and we measure the induced current. In the next part, we move it up and down. We measure the speed of the movement, and we measure we measure the induced voltage there. We measure the current to keep it stable. And we have our magnetic field. As mentioned before, this magnetic field BL is very difficult. Magnetic field times the length of the wire is a very uncertain value because it's very difficult to create a stable, constant magnetic field. So we can take the two BLs away and we sit with that equation. And because it's all physics, we need to have one more slide with equations. Don't worry about everything that's written there. The important part is this equation that shows us, because we talk a lot about the quantum standard and Planck's constant. And if we go back to this, to this equation, there's no Planck's constant. So we really need to see where this is coming from. And this is, if you go through all these mass and things, you see this is the equation that we sit with. Mg times speed, velocity is equal to Planck's constant and some other values. So currently, we use this equation to determine Planck's constant. Monday, we will use the equation like this. We will determine mass in terms of Planck's constant. So we'll use exactly the same equation, just shift the things a little bit around up to midnight, 19 May. That's what we do. Afterwards that. Okay, so what do we do in terms of the Kibble balance at Namisa? This is a picture of the NIST Kibble balance, and I like this one where this guy really concerned on what is going on here. So we're not going for that. As you've seen before, we're going for this very nice tabletop system. Currently, we have 2 engineers that's working at NPL. The aim is that we will get a system that works with a sphere of around 100 grams. That is what we will be using, not a kilogram. We don't plan to realize mass at a kilogram currently. We plan to go at smaller mass pieces. And we have developed a system based on an equal arm balance. It's outside, you can go and have a look. Also, as we've mentioned before, we also have some 3D printed things that we take around. And in cooperation with another company in South Africa, we are developing, they actually on our behalf is developing virtual reality system. That's also a display there. And there's something better actually coming where it's real full 3D, where you will have gloves and you can touch the thing and move it around. I don't understand anything about that, but luckily we have a lecture later today on that, and hopefully we'll understand much more. And this is really used for our student training, both internal student and school children, on getting them excited about this whole field. Okay, so I've said that we have this system. This is what it looked like, an old equal arm balance, and this is what it looks like now. And this is the prototype that we took to the Science Festival 2 months ago with a little small computer that can operate the whole thing. They've printed us some nice tools as well from plastic, but because you cannot use ordinary tools because of the magnetic field, they just all go together. So you need plastic tools, and we've got a set of mass pieces that we've also printed on the 3D printer. Okay, so what's happening in the very near future? We still need to procure quite a few of the quantum standards. This is gravimeter. As I've mentioned yesterday, it's in parts in our lab at the moment. It will be installed in the next 3 weeks. We need to get a Josephson array system, programmable Josephson array, to measure the voltage very accurately. We need to get a quantum Hall for our resistance standard, and we are busy with the development of a novel system to measure the speed of the movement with an interferometer. I get that wrong. Steph and Nkosi Pile is working on that system for us, and we're actually quite excited to see what's going to come out of that. Okay, so I think this is boring. So what does this new definition mean for us? For science, it really means that there's a whole new fields of research that's opening up. It's not just one field. It really encouraged multinational projects. The Avogadro Sphere project is really a good example of a multinational project. There's lots of people working on that. And as mentioned before, each country can realize their own unit in future. We don't have to rely on other people to do that for us. And I think a very important one is this one, that we can realize the mass scale wherever we want to do. We don't have to stick to a kilogram. And in the pharmaceutical industry, that is very important. If we can reduce the uncertainties on small mass values. Okay. So what are we doing about the other units that's being redefined? Currently, not a lot about the mole, but we'll look at this space in future. We are looking at the Boltzmann constant project, and currently we're not playing in that field, but there is plans to start with that in the very near future. And then in terms of the single electron work, we obviously will work together in future with UCT. The partnership means that they will do the development there. So what does 20 May 2019 mean for us? Ice will still melt in the same temperature as it melted on 19th May. The electronics in your cell phone will work exactly the same. Kelvin asked yesterday about, will he weigh less? No. The bathroom scale will show exactly the same as it done previously, but hopefully we will get better medicine because they would be able to do more accurate values for the masses that they use in medicine. And then this is the team, except for one new addition, Brian, that's not on the photo there, that joined after this photo has been taken. Okay. Thank you.
Thank you, Dr. Carsten. I'll allow for only 2 questions. Any questions about the revised SI program, so not project.
This one at the back.
This one.
You said you went for a smaller mass, I think 100 milligrams instead of a bigger one. Why was this? Why did you go for the smaller one instead of the big?
The reason why we go is not 100 milligrams, it's 100 grams. So order of 1,000, but it's fine. Factor of 1,000. All the original kibble balances were developed around 1 kilogram. Because of the redefinition, they had to measure a kilogram. Doing a kilogram means it's a very big system that you need. If you go for smaller mass pieces, you can go for a much smaller system, so the cost is reduced, first of all. And the other thing is you actually need to speak to the people in the mass field, because at the moment, 1 kilogram is where they know the best what is the uncertainty. Well, they know the uncertainty for 1 kilogram is the smallest. If they want to weigh 100 grams, the uncertainty increase because they have to weigh quite a few mass pieces to get down to 100 grams. So they talk about realizing the scale of the mass piece. So if you actually realize it at a smaller value, your uncertainty on that value is much smaller. Okay, makes sense.
Any other question?
There's one there.
Thank you very much for the presentation. I have 2 questions. You talked about the Kibble balance approach and the silicosphere. In ENMISA, which one are you going to use? Number 2, what would be the capital outlay to set up the Kibble balance or using the silicosphere?
That's a difficult one. NIMISA is going to realize mass with the Kibble balance in future. That is our plans. We actually need to talk about the cost later on because I sound like a politician now, but it's very difficult to determine that. It really depends on whether you want to go for the quantum standards to measure your voltage and your current, or whether you've got other ways of doing it relatively accurately. It depends on how accurate you want to realize your mass pieces. And that determines what is the cost. Because if you need to go for a quantum Hall system, it's in the order of 10 million rands Josephson array system is, I think, around 5 million rands. So let's have a talk about it afterwards. Whether you go 3D printed systems or you go with the NPL system. So there's quite a lot of things on how that will be determined. So, yes, okay.
So I'm Tim Pryor from the National Physical Laboratory in the UK. We're currently working on the Kibble balance, and we're very focused on the highest level systems at the moment. But the plan is over the next 5 to 10 years, this will translate into balances which will be more available at different levels of accuracy for different purposes. So I think the focus has been following the redefinition and working on the Planck's constant. We've been really focused on being the best possible system. Once that's shown to be operational, I think instrument companies will come in and actually will look to see how they can adapt that technology and make it more accessible to other people.
Thank you very much, Tim. Okay, thank you, Dr. Castan. Thank you. We'll have our next speaker. And she will be speaking about the Regional Reference Institute. Her name is Dr. Jane DeForce. She is the Director of Chemistry and Materials Technology at NMISA. And I'll just give her this opportunity.
Great, thank you. It's a very good morning, mid-morning, so I hope you're all still paying attention. So all protocols observed, so I don't have to greet everyone. So once my talk starts, we can get going. Has it fallen into one of those pockets that Mark was talking about? Oh dear. Who was talking about Industry 4.0? Technology. But then while we're waiting for the talk to start, to not waste time, I've actually been asked to speak about our Regional Reference Institute. Now, there was a little bit of history behind that, where back in 2011, I had this vision of starting an environmental pollution research and regulatory compliance center, almost like the CPCRC or whatever. And unfortunately, things just glided along and it never really took off. And even, it seems like we're off the air, but maybe I'm loud enough for everyone to hear me. So at the time, try it again, good. I think I'm loud enough though. But in any case, we really were focusing then on environmental pollution and not really looking at food, but at the time that was when chemistry started, and our focus was really looking at the air pollution monitoring, terrestrial, aquatic, and in the end, even your biota and your water, it gets into your food and eventually you eat it. So either you become a biological hazard yourself or you're healthy, one of the two. So life moves on. And we've gotten to that point now where it's expanded into more than just intriguing. It's expanded into more than just one concept. It's now becoming an institute in a sense, because we have to look in our backyard nationally as well as regionally. And as Oswald was pointing out, we do have the Continental Free Trade Agreement. Africa is seen as the breadbasket. And we are going to have to feed ourselves in the future, and there's more and more pollution, whether it's in the atmosphere as we breathe it or whether we're getting it in through just general bugs. But we're polluting ourselves terribly. Hello. And so we have to start looking at the actual testing. Now, the testing is one thing, but you also have to look at who is doing the testing, which is, in our field, the scientists that are doing the chemistry and the physics and the engineering. So eventually, in the end, we are going to be ultimately responsible for what we do and how we train the next generation to do the measurements that we're doing. Because what's the point of metrology? Why do you want to be reasonably certain of what your result is. Because I think if you go to the doctor and you are wrongly diagnosed for heart disease and you end up on troponone or something like that and you peg the next day, I think you're going to be a tad upset. And that's actually 10 to 1, and the reason around why we actually have to look at the measurements that we make and who does the training and the food that we're going to be eating. So I wonder if I should shush or keep talking. I'm entertaining everybody. Should I do Jennifer's bounce, bounce? Okay. Hold that. P 3003. It seems like whatever I did to my talk, I seem to have destroyed the technology. And it really is just animations. But what we are now aiming at and driving at, you've got the fundamentals of scientific metrology. We are collaborating a lot more closely with the NRCS because I think you are aware, or maybe you're not. We report to the Department of Trade and Industry, and there are 4 technical infrastructure facilities in a sense. It's metrology for measurement, which is the NMISA. You've got accreditation through SANAS. We have the NRCS for compulsory specification, and from that we borrow the legal metrology aspects. And last and not least is the South African Bureau of Standards, where the paper standards are promulgated. So all of this comes together, and we are now going to start looking at applying it in a more cohesive way. It's not a question of establishing a new institute. It's really just giving it a grand name. It's just a facility. It's not going to be one hub. It can be virtual in a sense, because you can't take the whole of the NMISA and turn it into one applied research institute. So what I really want to start sharing, if we can ever get this talk going, is the centers that we've identified that will actually take scientific metrology forward within the quality infrastructure and apply it. So the 8 centers that we more or less have pulled together is materials metrology, and then, gee, my memory is leaving me behind, but after that it is, yes, we're getting somewhere. I really do not know what went wrong with the technology. Okay, but anyway, if you can look at the customizable SI units, they're customizable because when you start to apply them, it's a question of what are you going to do with them. So, as I was talking about the Regional Reference Institute, there it is. We've invested a lot in scientific metrology, and many an NMI has done this as well, and I think the NPL is exemplary in that, and BTB and all the established NMIs. So our strategy is now to focus more on the applied metrology. So you're taking what we're learning, all of these fundamentals we've now heard about, from the Kibble balance to nice shiny spheres, but how are we going to apply them? And we're not detracting from the fact that you still need the scientific metrology, you need to work within the quality infrastructure framework, and how do you apply it in a sensible way? But one of the big things with the Regional Institute is the fact that you still have to focus on training, because knowledge doesn't transfer itself and a skill doesn't transfer itself. The bod that has to do the work has to actually have some knowledge of what they're doing. So I see it as a tree. And our CEO very kindly also used that analogy, where we've got our centers. As I was trying to remember them, I got to materials metrology and then my brain left me, and I think the sound is off again, or is it on? Okay, but anyway, we've got 8 centers that we have identified. But what I want to share here is that you can take the sci-fi science, you still need it, the fundamentals, within the quality infrastructure to get to the applied metrology, but you can't lose sight of the principles of science and, of course, the 2 bookends of engineering. So it involves all of the disciplines in the field of science. And even this mouse is anti-me. There we go. So keep focus on the 8 centers, which I will go through just quite quickly. Wow, this mouse is... I think the batteries are dying, so whoever speaks next, you'd better just get new batteries in this thing. But okay. If we look at Jesse's world, and he likes to advertise his materials characterization under materials metrology, they are assisting industry in material, knowledge of it, how to manufacture it, how to produce it, knowing what you are working with. And it can be anything from a new alloy to a few grams, nanoparticles. I mean, we're talking smaller than nano, you're going down into pico. And we've got very good equipment, which we are dying to have people use and we would like to use to service industry. so that we can look at structure, surface, whether it's in bulk or whether it's in small quantities. And then as part of materials metrology, don't lose sight of the fact that we still have our dimensional measurements. And at the moment, once I move out of my field, I'm claiming the Fifth Amendment, so if I say something wrong, I'm exonerated. So at the moment, we are looking at a couple of the measurements through refractive index and geometric dimension, where we've got quite a number of these coordinate measuring machines that can look at all kinds of angles, and you can do your car doors and you can do down to little nuts and bolts, which is very interesting. We have this lovely new gravity meter. I'm not totally sure of what measurements we're going to do with them, but it's quite exciting to watch that space. And there are very talented young bright minds in this in the organization and on the continent that will get involved in that. And then one of the elements that's quite important in additive manufacturing, I think hardness, that's why I put it at the top, because a lot can be done with hardness. Particle size is also done under math. So between our materials characterization team and our dimensional team, this is where a lot of the measurements will take place. Okay, and then we're moving on to energy efficiency. So in order for energy to be efficient, I suppose you need a smart light, and that's what they're going to focus on. There are rapid advances going on in the LEDs. I mean, every time we put a light fixture into our house, and if something blows, you end up not only replacing the lamp or the light, you take the whole structure out and replace the whole film fitting. It's actually quite frustrating. I don't know whether it's imported products, but it'll be nice if you can have some good lighting equipment, Natasha, that we can actually use. So when it comes to energy efficiency, we're looking at reference standards, because standards are always going to be there. Promoting high quality energy efficient lighting products. Then we're looking at luminous flux and versus power consumed, and we are accredited to do this. But in a nutshell, it's all about global colors. So that's what they will be doing and playing with. Then we go into time reference measurements. Sorry, I went one too far. I heard something about dark fiber, and when we do the discussion, we can maybe look at that, because maybe we can communicate between Johannesburg and Pretoria, I don't know. But this is more Steph's field. But we are playing around with time. Time impacts everything, whether you are doing your shopping, whether you want to get to home in time on your plane, or whether you're at the JSE. Time is of the essence, and in South Africa, we've got that big square kilometer array in Carnarvon. So we're getting involved in this space, and I think the measurements, this is something to explore, and I hope that we all can, collaborate around this and talk about it a bit. When it comes to radiation safety, we can play around with the name. Zakiti will probably think up something else, but it really is looking at the protection of the human body and also protecting the environment from those radioactive releases, because we never know when we're going to release what, where, and why. And of course, we do have our own NEMISA radiation experts. Sorry, I just want to go back to that if you can see the... I must admit, I don't know what is wrong with the technology, but it really is not up to speed. But in any case, I just wanted to make a joke and say there's Sibu Sisu, if anybody knows him, so we can all tell that joke. So in any case, when it comes to law enforcement, that was in one of the programs that Aletta was also alluding to. And it is dealing with forensic measurements. And I mean, my passion is in the forensic field because I am a bucket chemist. We're not going to start playing around with blood or anything like that and all those nice gory things. But what's important here when we start to collaborate more closely and get involved in drug analysis, because this was mentioned as part of the evidential breath alcohol testing, is that our road traffic control, I mean, drunk driving is not only going to be somebody who has had too many glasses of wine. When you think about it, those trucks that are driving, I mean, what's keeping them awake? And we've got some unique concoctions that are taken in our youth and environment. So we need to know, is it DACHA? I mean, now that you know that dear old Delta-9 tetrahydrocannabinol is now illegal, I was actually quite stunned because Canada is quite openly, I mean, they have shops where you can go and buy it. So we'll have to keep ourselves sober and look at, what else is causing the drunk driving, if you want to call it causing, and deal with it. So that's why we're getting involved in that space. And borrowing from, gee, this thing is magic. Just going back one more slide, if I can get back. Oh my goodness. Okay, one click. Okay, in our reference material production facility, where Maria is very active, this is where you start to really get into the chemistry sphere, where you need your certified reference materials and reference materials, because we do have very good technology that's at resonant acoustic mixing, or it's resonant acoustic mixing, where we can basically mix any material and we will take the space forward, and we can work with the Proudly South African logo, so we're very proud of that. And when it comes to health and the environment, South Africa, I don't know whether everybody else is aware, but we have signed the Stockholm Convention, which says that we as the NMISA, or as South Africa as a country, will ensure what it is there to protect humans. And that's why we are going to get into the space. We will be doing dioxin analysis. We're not going to be competing with private labs doing pesticide analysis. What we are looking at is the regulatory space. And that's where the air pollution monitoring and pesticide analysis will actually be looking at this space, not trying to now start offering it as a routine service. So it really is going to be those niche measurements where there isn't a measurement at the moment in the country. And same goes for ionizing radiation and sound measurements. Medical is the medical gases. So it's all diagnostic radiology. This is where all of the ionizing radiation will get done, brachytherapy, all of those things. And then you've got radioactivity and nuclear, because we do have the team in Cape Town that are still going to be contributing to health and the environment. There we go. And this little one is now getting into agriculture and food. And I just want to emphasize again, reference materials play a role here. And we will be focusing on reference measurements, food analyses, whether it's helping the police or collaborating with DAF, looking at dairy compositional testing, food labeling, food adulteration, bioanalysis as it's required. As you know, we had our listeriosis scare. But in the same space, Steph was talking to chirality, structured light, where can we apply it? And in the food space, that is actually where that application can come out quite strongly. Then, moving on from agriculture and food, this slide is very busy, but what I want to actually emphasize here with the Africa Food Safety Index, Addis Ababa had a very, very interesting, one of the first international conferences on the future of food safety, because I mean, that is something, food safety, food testing, it all applies to us. I will talk a little bit more about the AISC, but the big discussion is the Africa Food Safety Index and how we can contribute. Not so much as I'm talking about the Africa section, that's the AISC, but as a platform, you know, as an NMI, and this is not only NAMISA, this is talking to all of the NMIs, we can really operate in this space, because not every NMI has got a high-level food testing capability. So if we can partner with the right collaborators, we can actually look into that space. And what we are proposing, that we form part of that mainstream biannual food safety tracking and review process, because it's reported on per member state and it's scored. So this will just be another index that we will be looking at moving forward as the 43rd indicator. And I think as an NMI, we should actually be contributing to this. Now, this is also a busy slide, not to worry too much, but I want to just emphasize that with what Oswald has said, we are working in the quality infrastructure space. As we know about the Africa Continental Free Trade Agreement, we are going to be sharing food across borders. We want to start being able to trust the food that we eat as the food comes along our door. Because, I mean, you can walk into Woolworths, you can walk into any shop, but can you trust the food that is there? I mean, what testing actually is going on? Because, I mean, even on the shelves in Checkers, I mean, heavy metal testing is not really being carried out. So we need to be sure of who's testing what, where, and why. And that's where method alignment comes into play. And that's why an NGO like our AISC is so important, because it's a neutral platform really focused on the impact of food testing, mentoring young scientists, and ensuring that the testing that's done is actually kosher. That to me is important. Capacity building training that comes in, and we'll be talking to that now in the panel session. And then very important is networking and partnerships, because your suppliers are very, very important in this chain. And one of the things I just want to mention is that even though we have a section, the Sub-Saharan Africa section, we are looking at, there's a project now between Senegal, Ethiopia, Egypt, and I think it is Zimbabwe, where if we get them on board, we can actually expand it to then incorporate not only Sub-Saharan Africa, but the whole of Africa and have it as an Africa section. And then not to leave out the audits, because this is also reference measurements. We did start, I'm not going to be too exhaustive here, we did start with a lot of the work in PT. Is this one working? Thank you. Hopefully. I don't know. Can you hear me? This is, sure, all right, good. So I'm not talking to myself. Wonderful. So we have a couple of PT schemes that have expanded. We've got the sodium fluoride. We have, besides the pesticides in fruit, we've got organophosphate pesticides. A number of things are going on here. Then we also have the SADC water PT. And then one where Zakiti is involved, we are doing hospital audits. But hopefully that's not how you end up when we do get audited. And then the air pollution monitoring. I know there are many other interlaboratory comparisons that we are busy with, but we are going to pursue this space as one of the centers under the RRI. And we are going to do that in collaboration with the NLA and with SANAS. And then what I'd like to leave this is, okay, everything's gone off. I really do not understand what's going on. What I'd like to say is let's continue with the panel discussion, because everything that we're doing in those centers is impacting globally, but we as Africa, we'd like to be number one in this space. So I'd just like to call up Tim and Jennifer, if you don't mind coming up, and Wynand, if you don't mind. Thank you. Yes. I told you, you were primed. CEO? Do you want to come up? It sucks.
Thank you, Jane. You will lead the session.
I will lead the session. Okay. Yes. So why I'm calling a panel, see how much time we have. Yay, we've got lots of time. Because it's all very well taking the fundamentals and working in the quality infrastructure and applying it moving forward. It needs some expertise and it needs some training, it needs some sensible guidance. So I'm going to ask the experts to talk to this space, you know, because we're not literally going to close down the metrology functionality of maintaining and keeping. This is all about the dissemination, because otherwise why are we doing it? So Tim, if I can maybe kick you off, maybe you can just highlight a few of the really key things that we should be thinking about.
This one doesn't work, I don't get it. So, NMIs have a number of roles. One of the key things is the scientific metrology, to enable that to be there to help people move forward. But doing that is only one element of what is required. You have to make sure that any knowledge that's generated within the NMI actually gets to the people who need it. And I think for that, training is absolutely essential. Knowing what is needed, why it's needed, and the ability to apply it is absolutely essential. Otherwise, quite a lot of what we do in the NMIs is sort of could be considered irrelevant if it doesn't get to the right people. And I'm giving a presentation later on, so
Yes.
if you, I'll give a little bit more information later.
And on your comment?
Yes, I was thinking of when we started our chemical metrology and what our plans were at that time. And people are asking us, why are we changing direction now, going into the more practical side? And I then want always remind them that when we started our chemical metrology in late 1990s, we knew exactly what our gas was going to do, the primary reference gas mixtures. Our inorganic section, we're going to certify the South African reference materials produced in those days by Mintec, one of our scientific institutes, science councils in the country. And then we started organic, and we started off by sending our people for training internationally and learn how to prepare certified reference materials, how to develop methods, and so on. But the idea was always to get to the point where we can produce certified reference materials, matrix reference materials, do reference analysis for our national needs, and then of course for our regional needs. So to just follow on what Tim has said, you always need that high level scientific metrology, the development of the methods and everything, but then the most importantly, I think, is then to disseminate that in a way that really benefits your economy, your regional and continental economy?
I think just to add on what colleagues are saying, let me first start by saying it is Africa Month. And it is very important for us to stay true to our identity of being African and not trying to be something else because other people in other parts of the world are doing it and they're doing it very well for their benefit. Let's look at what benefits us. And in our strategy, when we looked at the application of the good science that we've developed over the years, we looked at what does our environment, what does our economy, what does our governments need. And usually, I think at NEMISA, used the example of when the listeriosis outbreak hit us. I was in an unfortunate position of having to go give a report to the Portfolio Committee on Trade and Industry in Parliament. And the first question they asked is, what are you doing to resolve the listeriosis challenge that we are facing? And they are asking because they know there are lots of capabilities that we have in the country, but with those capabilities, why are we having such simple challenges that we could resolve quite easily without spending a lot of money hitting us at such critical moments in our development? That sets us back many years because of our inability to be proactive in resolving those issues. And when we looked at our strategy, we said, let's have centers that would serve in a proactive way the need of our economy, our need as African countries. And I said yesterday during my presentation, let's think of the Africa Free Trade area discussion that we have on the table. If there is a dispute in the measurements that are made in one part of the continent and the goods are traded in the other part of the continent and there's a dispute, how are we going to resolve it? At the moment, the truth and reality is we don't know. And what we are saying is proactively set up reference facilities that could either be at NEMISA or wherever in the continent that would be able to give us that mechanism that allows our economy to develop and facilitate trade, the safety of the population, and so on. So it is important to be relevant as NMIs, that we can have as many CMCs as we like. If we cannot apply them to the population, it is irrelevant at the end of the day.
And I think a key part of that is going out to industry and talking to them about what their actual needs are. And a part of that is explaining to them sort of why measurements are important. Because if industry doesn't really understand sort of what we're doing and why we're measuring things so accurately, they're not really going to appreciate or use our training that we might develop that we think they need. And I think you spoke on this the other day where you say, we've got a solution for your problem. What is your problem? I thought that was a really good way of thinking about it. You know, you need to engage with industry, engage with your economy, engage with the people that need it to really understand what capacity you need. And part of that is going out and talking to them about what measurement is and why it's important.
So yes, I think customization to what people actually need is incredibly important. There is also a key message here that we should all do this in partnership. None of us have the resources to address all of these things, and there are bits of expertise all over the place. So recognising where people have strengths and then collaborating and forming partnerships, I think, is the way to solve this.
Because I'd just like to, is there anybody in the audience, because Martin, I'd actually also like to have your opinion, if you don't mind, if I can just take the mic to you. Because one of the things I've noticed when people come to you with a problem as an industry person, they have a problem, but they don't really know how to concisely articulate what their issue is. Then they send us an email and they want us to test the most bizarre thing that you've never heard about. And as an NMI, you're not always perfectly set up or geared to do a very specific analysis. So, you know, that's where that partnership comes in, where you've got your research, you've got an NMI, and you've got industry, where you come together to understand what the problem is, to then eventually be able to, I think, assist properly and not be misunderstood.
Okay, surprise, surprise.
Surprise, surprise.
My name is Martin Kaiser. I'm representing PDB Germany, but not the Metrology Institute. By profession, I'm a pure or poor economist. So
That's
no
why I wanted
idea
the
about
economy.
physics. I'm representing the PDB as being a development partner assisted by the German government to assist specifically African countries in the field of quality infrastructure in general. So first of all, I don't want to answer that question. I want to come to the point that we are very happy to see that something like a training center is or will be established at the ground of NISA, due to the fact that up to now we are using in the development partners world more or less the Metrology Institute in Turkey, UME, because they have really those facilities available which are really tailor-made. There is even a small hotel, so it makes it easy for us as a development partner to send trainees to Turkey. Nevertheless, that's the Turkish approach. We would really like to see, it was said by the CEO of MISA, this is Africa here. And also, I really very much appreciated the fact when you have presented your slide about the Training Institute, that you have combined industrial, scientific industrial, as well as legal metrology. And I think this is exactly what was said. We have to make, whatever we do in that world, we have to make it, demand-oriented, where is demand, and to make people understand why metrology is needed. And if we do it in an African way, I think this is much better than, for example, to send some metrologists to Germany, to NPL UK, because it's sometimes a bit away from the reality here in Africa. Therefore, I'm very, very happy to see that something like a training center, training institute is on its ground, and I can promise you, PDB Germany, we will be happy to make use out of it.
Wonderful. Okay, John?
Thank you, Jane. If I may add on to that, I'm John Wilson. I do a lot of work in developing countries with establishing NMIs, often with the funded projects. And where I have seen money absolutely wasted is really horrible, where funding has come to an NMI to try and establish them to a level where they have primary standards. And when that equipment is installed and going, and then you say, right, now let's do some calibration work, then you find that they haven't got anything that can be used in that field. So the appeal is that if you are going to establish standards, make sure that they're fit for purpose for the industry that you address, that you know what the workload is that you are going to need to do at your NMI, that you train your people exactly as Martin and others have said, to the right level that they can do that work, and when you've accomplished that, you are competent with that, then go for the next level up, and so on to the next level up. And that way you will be able to service your industry locally well and be useful to them.
I think that's a very good point. I think one approach to this is to actually look at the relevant industries and the technologies that you're trying to move forward and build roadmaps. Look at what your aspirations are and where you want to go, and then put the metrology and the measurement infrastructure in at each stage that you need it. Don't necessarily go for the absolute top right at the beginning, because all that investment may not be appropriate to your first step in your roadmap.
Yeah, I think what John and Tim said is extremely important. On Tuesday, we had a meeting of the directors of the NMIs and the legal metrology bodies in Africa. And the next big question for us as African countries is, with our African Continental Free Trade Area, the AFCFTA, what will the countries in Africa actually need to participate in intra-Africa trade? If we look at this whole metrology system, and we tend to look at the international system and the BIBM, CIBM, your calibration and measurement capabilities that you want to get published, approved and published internationally. But there's a big problem in Africa in the sense that our intra-trade, so amongst African countries, are extremely low. I saw a figure a few years ago of 3% of our total trade is intra-trade. So what do we tend to do? We try to trade with the rest of the world outside Africa. Of course, there's money there, big countries, Asia Pacific, Europe, the United States is big markets, the UK, really big markets. And of course, we must export to them. But there's a huge market in Africa for our products. And if we can get the system in place, fit for purpose, and can agree, this is the testing that we would accept from our neighboring country for their products to be allowed into our country. I think that will be a tremendous step. And we spoke about, we've got a map at the moment that shows colors. If there's a metrology institute in that country, then we give it a certain color. If there's nothing, it's red. So we were trying, when we established AfriMets, we said, oh, this is how the map looks with a lot of red. A few countries with scientific metrology institutes, and we want to get it to gold. That's the highest level, everyone member states of the Meter Convention. But what we should probably do now, oh, and by the way, that map is looking a lot better now.
It is.
But by the way, now, it probably is more important to have a map of, in the first place, define what do we need to have in place, and what do we agree on for this intra-Africa trade. And work very closely with all the discussions on the AFCFTA, the Technical Barrier to Trade Committee, and everything. Do the TOR, the terms of reference for that, then make a map, and then get that map green, so
Yes.
that we can have intra-trade.
I'm going to say something that I've said when we had the food safety workshop here. I think it was in this hotel last year.
In June?
And I'm going to say it because the AUC representative on the TI is here. Martin, I'm not an economist. I'm a self-made economist. And I can say with certainty, and I believe most people in the room will concur, that the intra-Africa trade that we are talking about and discussing is going to be trading in 90% imported goods.
It's bad.
And that is not a good position to be in. So in essence, for me, it then says it doesn't make sense to have intra-Africa trade if we were to just take other people's goods and start trading in there. If I was a politician, I'm not one, I would say it's intra-Africa trade, and the only discussion we have should be on goods manufactured on the African continent, and that's what we are discussing. The others, you handle them in your own country the way you handle them. Once they enter, they stay there. But I believe that's why God didn't make me a politician. But the point I'm trying to make is, we find it difficult between ourselves to collaborate and cooperate. And I think I just want to emphasize what Dr. Lowe has started raising now, that it is important that we look at what is relevant for us and start making developments that are relevant to us, collaborating amongst ourselves. And if we ask, and I think the question was asked yesterday during the session,